we're going to get into writing numbers in scientific notation. Scientific notation is a way of taking numbers that are really big or really small and writing them in a more reasonable form. It makes it easier to compare things instead of having to read a whole bunch of zeros. To be honest, I start to struggle. I'm not sure I can picture the difference between 10,000 and 100,000, certainly not between a million and a billion. I mean, they both just look like lots to me, and I don't have a good grasp of those differences, and I certainly don't have a good grasp of the tiny ones either. This isn't just something that we come across on a regular basis, so it's something that we've not really learned or get used to, and even with doing this for a long time, I still have trouble picturing these really big and really tiny numbers. But scientific notation is a way to help us look at those numbers. And I'm spending a little bit of time here on this one because one of the first times that I really had the opportunity to teach was scientific notation. And it's a kind of funny story. I kind of began to know in late high school that I was considering teaching, kind of wanting to teach. Scientific notation and algebra were things that came easy to me when I was in junior high. But at that time, my sister was in junior high. And I had taught some informal lessons at my church and such, but I've not really taught math or science specifically. It's what I knew I wanted to do, teach science, that is, but I hadn't really had the opportunities to teach those topics. Yeah, maybe helping a friend with a homework problem, though to be honest, I was receiving help more than I was helping them, I feel like. And I did not like tutoring. I was not a social person, so I never volunteered to do that when the school would ask for them. But my sister was learning scientific notation, and she was really struggling with it. And so I sat down with her, and I didn't have the skills of a teacher that I have now because I hadn't really been trained how to do teaching and hadn't practiced a lot. So what I did is I worked out the problem for her. And in working out the problem, she had the answer. Well, she just wanted to copy down the answer. And I knew that wasn't good for her. And so I ended up taking those answers and stealing them from her. And she literally ended up chasing me around the house. And I literally, at some point, after trying to tear up the page and throw it away, and she still was like digging in the trash, I got it back from her, and I took it and I shoved it in my mouth and chewed it and swallowed the darn thing. And so my parents were furious at me for this, and they didn't really understand what I was trying to do. But my sister was so frustrated with this, and I was really having trouble teaching it to her because it had come naturally to me. Like I said, I didn't have those skills for teaching it. But as I said, scientific notation is a way of writing numbers that are really big or really small. A single strand of hair, and you can't see that one I just plucked out there. I promise you I did. But a single strand of hair is about a millionth of a meter wide. And your head has something like 100,000 hairs on it. And so we have both a really big number there and a really tiny number there. And so we can use scientific notation to write that. And I want to go into how to do that. So first off, we have this thing out in front that is our coefficient. It's our number. And then over here we have what's called a power of 10. Now, if you punch in 10 to the 2 or 10 squared into your calculator, you will see that that is 100. So really what we're saying here is we take 1.5 and we multiply it by 100 and we'll get, in this case, 150. Now, 150 isn't a number that I would personally choose to write in scientific notation. It's a normal number. I can picture 150, no problem. There might be times where there's a reason why you would want to, especially if you're doing comparison of, say, this number to some bigger numbers, where having the scientific notation can be helpful. What we do in scientific notation is we always have that coefficient be between 1 and 10. Because if it's 10, well, then we could just do another power of 10 there and move that decimal one more, and we're just multiplying by a bigger number. And so we always want a coefficient that is more than 1 but less than 10, which means you will always have a number before the decimal, a single number in the ones place before the decimal, and then you may have numbers in the decimal, you may have multiple numbers in the decimal or not. Now, this one here shows moving the places, and I found that students struggle with scientific notation not because they don't understand the idea, but because they forget which direction is the right one to go in this time. The other thing is here, if I have a standard number and I want to turn it into scientific notation, here I move the 3 to the left here. But if I want to take this number and turn it back into a standard number, I'm going to move it 3 to the right here. But you'll notice for this one, the standard number, we move the decimal to the right, and to undo it, we move it to the left. And so we do opposites, and because we have both, this one's right to left versus left to right, it just confuses students. So honestly, what I want you to do is I want you to think of that 10 to the 2 that we had here just a moment ago, where that 10 to the 2 is 100. And I want you to go even simpler. I want you to remember that 10 to the 1, anything raised to the 1 power, is 10. And 10 to the negative 1 is 0.1. I have found that remembering a simple example like this helps students know whether the power out here should be positive or negative, and which direction to move the decimal, whether the number should be getting bigger or smaller. So for example, if I take the digits that they have here, they have 2400. What I look at that and do, and I'm trying to remember which way do I want to move the decimal. Well, I know I only want one thing before the decimal, so I'm just going to move my decimal there. I know that that's 3 places, so I'm going to multiply that by 10, but I can't remember whether this is a positive 3 or a negative 3. Well, what I imagine is these two here. If I take 2.4 and multiply it by 10 to the 1, which is the same thing as 10, do I get a bigger number or a smaller number? Oh, 2.4 times 10, that's easy. It's 24. And if it's not easy for you, punch it into your calculator. Oh, it's 24. That made my number bigger. A positive exponent makes the number bigger. Well, since here I have a big number, then I need a positive exponent here to make it a bigger number. And then the other thing is I just put my decimal right here into this 2,400. And so I didn't drop the zeros. But the proper way of doing this gets rid of those zeros in your scientific notation. You wouldn't normally have that big of a gap. You understand why I do. But 2.4 times 10 to the 3 is the correct answer there. Now, I found a lot of students, that's enough. They don't even have to remember this 10 to the negative 1 example because they've memorized the 10 example and the other one's opposite. So here, if I have this number, I'm not even going to try to remember the name for that. We've got digits out in the tens and 10,000ths and 100,000ths place. And so what I'm going to do is I know that I have this number and it's 8.6. They've already counted out that is 4 places for me, but of course I can count moving the decimal 1, 2, 3, 4 places, okay? So now I know that's going to be 10 times 10 raised to the, again, if you memorize this example, great, but a lot of students say, oh, multiplying by 10 makes it a bigger number, that's a positive coefficient, this is a smaller number, it has to be the opposite. Well, if it's the opposite, then it's a negative coefficient. And then we moved it 4 places. What those powers literally mean is how many times we're multiplying by 10. So if we have 10,000 here, if I write this as scientific notation, it's going to be 1 times 10 to the 4. Literally, what that means is I'm multiplying it by 10 4 times. But the way we show that is times 10 to the 4 instead. And then 1,000 is 10 to the 3, 100 is 10 to the 2, 10 is 10 to the 1, and anything raised to the 0th power is 1, and so 1 times 1 is 1. And so we're not multiplying 1 by 10 any times. And we're not multiplying it by 0, we're multiplying it by 10 0 times. And so then it ends up just being 1. To be honest, I don't know why they have this out here. It's pointless over here. To be honest, this here is the title there. That column just doesn't belong. You don't need to memorize these. But they're trying to show how you can use powers of 10 to get bigger and smaller. Now, these here, they're trying to show how they're multiples of 10, which is why we're doing a multiply by 1 over 10. Really, it's the same thing as dividing by 10. Dividing by 10 is the opposite of multiplying, and so it's the same thing. But here we can get tinier numbers. This here is just a table of examples then of some times where maybe we would want a scientific notation number. There is kind of, and you're probably familiar with this one way here. Right here, we have 550, let's see, that's 3, hundreds, thousands, millions, billions, 550 billion. you're probably comfortable with reading 550 billion liters. And literally, what that means is 550 times 1 billion. Well, when you do that, you get this number here. Well, 1 billion is the same thing as multiplying 10 by itself 9 times. So now we have 550 times 10 to the 9th. Well, that's improper scientific notation. There might be times where if we're wanting to compare the amount of gas used in other countries and their values all come out to be 10 to the 9th, where we want to leave America's in this instead of change it to 10 to the 11th, because then it becomes, okay, I understand that 11 is bigger than 9, so 10 to the 11th is bigger than 10 to the 9th, but how much bigger? It gets a little bit ugly. Whereas if we have 550 times 10 to the 9th, and we compare that to, say, another country that only uses 3 times 10 to the 9th, I can see the 10 to the 9ths are the same, and I can focus on the 3 to 550. We use almost 200 times more than they do. Not quite, I don't want to do that math in my head, but you get the idea. There are occasions where, for comparison purposes, improper scientific notation is okay. But what we can also do is we can take improper scientific notation and we can turn it into proper. I can take this one and I can move the decimal 2 more. If I move the decimal 2 more, I've made this number tinier, so this number has to become bigger. Moving it 2 more, 9, add 2, 11. There's a whole bunch of other examples here, both of the big and of the small. And over here's more of the same. They just have it written out in comparing both formats. So there you go. Punching this into a calculator. You do not want to type in times 10 raised to the 4th. It works about half the time. And it works about half the time because times 10 is a math operation. It's a multiplying. When you're following something called order of operations that you got in pre-algebra or algebra, hopefully, when you're following those, it turns out that multiplying happens after powers. And so sometimes that gets screwed up. Your calculator has a way of doing this. It is going to be on your calculator as an EE button or an EXP button. And that EE or EXP will be displayed one of, I'm going to go with 4 ways. They show 3 over here. There's another way that some modern calculators will do it, but they'll leave a gap in here. That gap implies the times 10. They'll put the 06 here like that. The 0 in front of it implies that it's a scientific notation. If we're just doing a power, it'd be a 6, but to be honest, 4 to the 6th power gets confused with this one easily. This one is not used by calculators a lot. To be honest, this one's not used by calculators a lot. Instead, what they do is they take the E from that exponent, or the EE, and they turn it into an E on the screen. That E stands for, takes the place of times 10 raised to that. It takes care of the superscript there. And so 4E6, when you type that on your calculator, 4E6, it will display it like this and means this. Some of the newer, nicer graphing calculators, when you use that E button, it will display it as 4 times 10 to the 6th, which is great because that's what it's supposed to be. But that E stands for times 10 raised to the. It takes place of all of that. And because of that, it will follow order of operations, because this here isn't genuinely multiplying. We are not actually multiplying 4 times 10 to the 6th. What we are doing is we are writing out 4 million, the number, a different way. And so 4 million is 4 times 10 to the 6th, but this is a number and not 4 times 10. It's not 10 raised to the 6th power. It's the same as, but they are different. And so on your calculator, use that exponent button. Also, I'm going to be a little bit of a jerk about this, but when it comes time to giving me an answer, when you do a calculation, you get an answer like 2.5e negative 4. I want to see that written out. It's 2.5 times 10 to the negative 4th. Yes, I will penalize you for writing e. It's just how calculators do. It's what happens when you have what's called a 7-segment display, where you have just the boxy things to work with, and it's difficult to display it. Phones, some of the nicer modern calculators, they will actually show it as times 10 raised to the, and you're lucky if so, but there you go. I'm going to cut into here showing you how to actually type that into the calculator. Hopefully these directions are clear enough, but I think it's easier if you can see it. I've got some software that lets me show what a Texas Instruments graphing calculator looks like. Most of the handheld calculators are Texas Instruments as well, the scientific ones, and they're very similar. And I'll show you how to do it on other computer-based calculators, though you won't be allowed to use a computer on the test, a computer calculator for the test, or a phone calculator for the test, although there is a for the test that we do online on Blackboard, there is a built-in calculator with the test. That one you're allowed to use. You just can't go use other websites because, of course, that brings up, cheating possibilities. And so I'll show you how to do it on the computer and on a calculator, because reality is you're probably going to use your phone or use a computer for doing your homework. Discourage you from not practicing using it on a regular calculator, because come test time you're going to have to use this, and if you're not familiar with it, you're going to stumble. And I recommend having your own calculator, because it's what you get used to practicing, and it's what you're good at using then. But I'm going to cut in a video clip here where I show you how to do that, and then I'll cut back to the slides that I'm actually advancing to right now. So here I have software that's designed to mimic Texas Instruments calculators. Specifically, it's the TI-84 Color, which is pretty much identical to the TI-84 Plus and 84 Plus Silver Edition, and fairly similar to some of the older versions as well. They all work just about the same. The only difference is where that EE button might be different. So, for example, one number that we'll use a lot this year is Avogadro's number, 6.02 times 10 to the 23. Well, if I want to actually write that out, this is not the way to do that. 6.02 times 10 raised to the 23. It just does not work out properly. It doesn't follow order of operations properly about half the time. It turns out it's a numerator-denominator issue, and there is a way around it with parentheses, but don't get into the habit of doing this. Instead, what you want to do is you want to do 6.02, and as I said, you want to look for that exponent button. On this calculator, it is a second function, and it is above the comma there. It is this EE here that you're looking for. And that EE, I believe they use two E's to distinguish it from the alphabet E that's on this one. There's a alphabetical E over here above the sign, or as I like to joke, the sin button, but the green alphabet letter there. It is different than the alphabet E. See, they even look different on the screen. I'm going to go here and delete that. But this E takes the place of times 10 raised to the. So then all I need is that coefficient, which was 23. And there we have 6.022 times 10 to the 23. Now, if I want to do math with that, 6 times 6.022 second, comma, 23. Notice this number is big enough, it's spitting out my answer in scientific notation anyway. Oh, I added some extra decimals, is what I was forced to learn as a student. We're only going to go out to 6.02. Anyway, there is our answer. It's in scientific notation. I'm totally fine with answers being reported in scientific notation, but I don't want you to write this out as a standard number either, because I don't want to count those zeros. But remember, when you write it out, you're going to replace that E with times 10 raised to the. What I want to show you is what happens if we try to do the reverse process here. If I take this one and I divide it by 6.022 times 10 to the 23. And so I'm going to do divided by 6.022 second, comma, 23. Gives us 2. That's what we expect, because we just undid what we had done a moment ago. However, if I come up here and I grab that prior answer again, so what I did there is I went up twice and then I hit enter on my keyboard rather than enter on the screen here. It's just habit. If I try to type that in wrong, I want to show you why this doesn't work. If I do divided by 6.022 2.0, since I use 2.2, I got to stick with using the 2.2. 2.2 times 10 caret 23. If this was the correct way to type it in, it should give us the same answer. And it does not. It gives us 2 times 10 to the 46, not 2. What happened? Well, what it did is it followed order of operations. It divided this number by 6, and then it multiplied that answer by 10 to the 23, which is almost a trillion. And so it moved the times 10 to the 23 to the numerator, because it doesn't know that when you wrote 10 here, you meant scientific notation 10 and not multiply 10. So it is easier just to always do the exponent thing. As long as we're here, I want to show you one other thing. It turns out you can make your calculator remember this number. It works only if you're using a graphing, also known as programmable calculator. But I want to show you how to do that real quick. 6.02, second, comma, EE on the screen, or on the calculator, E on the screen, 23. We will use that number a lot. It's called Avogadro's number. There's a way you can save this in your calculator so you don't have to type it every time. The way to save that is over here, right above the on button, is the store button, STO with an arrow. And it will display as just an arrow on the screen. But now you're telling it to store this number, to save this number, to remember this number. And we got to pick a variable, so I'm going to choose alpha A. Sorry, alpha, and I got to actually hit A there. Now, I'm telling this to store this number as A, to remember that this number, that when I type in A, it's this number really. And so now when I do that, it's just going to say 6.02 times 10 to the, times 10 to the 23. It displays it as the E, of course, but it just shows that. And you're like, well, did it do anything? Well, watch this. If I do this calculation here again, 2 times alpha A, it gives me the same answer. Now, we just scrolled away from that answer, but if you you can look at here, we use the answer function, and you can see those are the same, other than the fact that I just did the 0.02 instead of the 0.022. And so it now remembers that A is that. The only thing I'll caution you is if you get into using this for programming, and I actually got my start in computer programming using a programmable calculator, which is what we called graphing calculators back in my day, in the mid-90s. Sometimes A will be used as a variable in the program, and it will forget what this A is. Also, if you download games to your calculator, which there is an option to do that, I'll let you research how to do it, but if you play around with the games or use some of the apps that are built into this, occasionally they will store a variable under A, and you will get it overwritten. So it never hurts to, on occasion, check, certainly before a test, check alpha A, enter, oh, there, I got what I expected. The other thing, it is possible to get your calculator to spit out scientific notation. Once you get to a number that's too big, or rather than using my mouse, I'm just going to write out a big number here. When I do that, I think it's anything more than 8, it will turn it into scientific notation automatically. And there we get, hey, hit 13 times again. So there we go. It'll display it in scientific notation. You can get it to display 100 in scientific notation as well if you want. So what you can do is you can come up here and do mode, and you can tell instead of doing normal to do it as scientific notation. So now when I click mode and get out of this, nope, when I hit second quit and get out of this, now when I type in 100 it gives me as 182. And that is proper scientific notation for this one. The downside is it does it for everything. And so I personally don't like doing that, but certainly you're doing a calculation and you get some answer, and that answer needs to be in scientific notation, but on your calculator isn't showing it. Well, then come in here, hit mode, change it to scientific, and go second answer to pull up your previous answer, enter, and it will display it in scientific notation for you. So let me real quick show this. If I have, let's say, the speed of light, it's something like 299, and then I don't remember the rest of the digits, so we're just going to mix them up like that. So I do some calculation, I get this as the answer, and I want it in scientific notation. mode, switch over to scientific, second, quit, and now I can just enter or second answer, and it will pull that number and spit it out in scientific notation for me. Now, this is not a useful scientific notation because we're not dropping a whole bunch of zeros, and normally that's what is done. Speed of light is normally written as, it's rounded. As long as I count my zeros correct there, yes I did, we get 3 times 10 to the 8th. And so that's how you do it here. It's too hard for me to record a phone, and each phone is different, and then of course there's different apps if you don't use the default built-in one, so I'm not going to show all those, but I will show you here real quick that Google has a built-in calculator. Notice it even wants to autocomplete times 10 to the 23 for me. But notice it displays it as a lowercase e instead. However, if I want to type that, I can go 6.02e23, and it reads that as 6.022 times 10 to the 23, and then I want to multiply that by 2, and we get the same answer we had just a moment ago. And so you can see, again, that you can just type e. What's different here is you can type it as a capital or lowercase e on this one, and it will recognize it as that, but it reads you typing e as times 10 raised to that. And again, if you want to divide by it, using e is essential. Do not get into the habit of typing times 10 caret for the superscript 23 or whatever the number is. Also be careful, I mentioned it earlier, but different programs use a negative sign versus a minus sign. Beyond that, most calculators are similar, but every one is different, and if you're not sure how to do it, obviously, how do I type scientific notation on my Casio, whatever the heck the number is? And I don't know the Casio make and model numbers, but here you can find videos or you can find articles, etc., etc. Google's your friend in that case if you don't know how to use your own calculator and don't want to go reading through the manual. I can try to help you, but it's different, slightly different on each calculators. It should be basically like those processes. Anyway, back to the notes. Again, like I said, when the calculator gives you a power of 10 answer, you need to write it out as a scientific notation answer. Here they're just showing that again. What they're saying is that on many of them, it's a not direct one, and on the video clip I just showed you, it is not direct, so we're skipping that side. Writing these two out in scientific notation. So I'm going to take the decimal here, and I'm going to move it 1, 2, 3, 4. So that's going to be 6.4 times 10 raised to the 4. I need to figure out whether it's positive or negative. Let's see here. I want to take 6.4 and make it a bigger number. That's the same as multiplying by 10. 10 is a positive number, so positive there. Well, 10's got a positive 1 up there as its coefficient, so positive there. Process elimination, then I know this was going to come out to be negative, but I do the same kind of thing, and it's genuinely how I think through these kinds of problems. I don't memorize directions. I just don't. I don't remember which way to go. Honestly. Anyway, that one's going to become 2.1. I moved it 2 places. I moved it the other direction, and we're going from a normal number to scientific notation, so that's going to be a negative. Or in other words, I've got 2.1. If I multiply it by 10, that's going to give me a bigger number. So it can't be 10 to the positive 1, so it has to be 10 to the negative something. Over here, we have multiple guess, which makes this nice, because then it's been done for us already. So we're going to go 1, 2, 3, 4, 5, 6. So that's 8 times 10 to the 6. And then we need to figure out whether it's positive or negative. It's a smaller number. This number is smaller than my 8 here, so it's going to be a negative. That gives us that one. This one here, 3, 6, 7. Those commas are in there to separate threes. You'll see spaces like this sometimes as well. We don't tend to use commas after the decimal, so the spaces are nice. Certainly if the spaces aren't there, you still count the same. I just count by ones when there's not the spaces, but when there's the spaces, I do the skip counting 3, 6, 7. So we've got 7.2 times 10 to the 7. And then I need a something out here. Is it going to be positive or negative? It turns out it's going to be positive, and so that's going to give me this one here. As a side note, this is the same number. It's just improper scientific notation, and this one's the same number. It's just improper scientific notation. These two are the wrong answers. And I'll leave it to you as a challenge. I would encourage you. You want some extra practice? Turn this into a regular number and turn this one into a regular number. It's not these. Great extra practice. Anyway, that finishes this section. The chapter always ends with a concept map. They're of limited use. I would encourage you to take the time to look through it. I will only review it on occasion. I don't think this one is worth reviewing, but of course, be sure if you have any questions that you let me know.